Digital signature provide a way to verify the authenticity of the message and for validating if the message has been altered during transit. Digital signature relies on asymmetric cryptography. It provides authenticity and integrity services for messages transmitted through a non-secure channel, also known as public channel. Because of the use of the private key, the message could only have been signed by the claim sender who does own the key. And as such, the recipient of the message has reason to believe that the message was indeed sent by the claim sender, and that is called authenticity. And also the recipient has reason to believe that the message has not been modified during transit if the digital signature verification was proven to be successful. And that is called integrated service. You can think of digital signature as, for example, shown in the figure here, like traditional handwritten signatures. But if it is properly implemented, in fact, digital signatures can be much more difficult to forge compared to the handwritten signatures. Additionally, digital signature, in fact, also provides non-repudiation service. It means that if the signer who signed the message has signed a message and sent over the message, he cannot later on, he cannot deny the fact that he is the one who indeed signed over the message. He has to take accountability because of the use of private key, because he is the only one who has a private key, and he is the only one who could have signed the signature. And that is called non-repudiation service. Now, let us discuss the steps that are involved in digital signing and verification process. Let us start with signing. First of all, Alice is the one, again, we are using our running example again. Alice is a sender who wants to send a message, and Bob is a receiver who will receive the message. First of all, Alice has to generate an ISA, public key and private key pairs. And next, Alice computes the digital signature, denoted as SIG, on her message, the message M that she wants to transmit. And the computation is used, signature is computed by using this formula here given, which is the actual formula for signing the message M. This formula can be read as follows. Compute the hash of M. Compute the hash of M first, and then you raise the result to the power of D, and you take the modulus N. Let me repeat. Compute the hash of M, raise to the power of D, take modulus N, and the resulting value is called digital signature, SIG. And take note that such digital signature for the message M can only be generated by Alice, who owns the private key. Because private key is supposed to be private, nobody else should have the key. And as such, Alice must be the one who indeed signed for the message. And once she has signed for that message, Alice sends both message M and the signature SIG to Bob over a public channel. It can be sent over a public channel. It doesn't have to be the secure channel. And that is a key property of using digital signatures. Next, I will discuss about the verification process. Before that, I have to explain about one key important property of asymmetric cryptosystem to make things clearer.